So the first problem based on the reduction of quadratic form to canonical form. So reduce the quadratic form 6x square plus 3y square plus 3z square minus 4xy minus 2yz plus 4zx into the quadratic canonical form by means of an orthogonal transformation. So this is the problem. So now first we have to find out the matrix of the quadratic form, because we know the working rule. From the working rule, first we have to find out the matrix of the given quadratic form. So what is the matrix of the quadratic form? This is the formula. Capital A is the first term, the coefficient of x square, of the coefficient of xy, of the coefficient of zx by this way. So similarly here the quadratic form, the coefficient of x square is 6. So the first term is 6. And of the coefficient of xy, what is the coefficient of xy? Minus 4. Divide by 2, minus 2. So that it is minus 2. If it is minus 2, obviously here also minus 2. And the coefficient of here is of the coefficient of zx. So zx coefficient is 4. Divide by 2, it is 2. So if it is 2, obviously in the term also 2. And here similarly by this way we can substitute all the value. So we can find the matrix of the given quadratic form. So this is the matrix of the quadratic form. And now by the working rule we have to find out the characteristic equation for A. So we know the characteristic equation formula for the given matrix, and also the given matrix is symmetric. Okay, because symmetric means the terms are equal, Aij equal to Aji. So the terms equals here. And now the characteristic equation of A is, for the 3 by 3 matrix, lambda cube minus s1 lambda square plus s2 lambda minus s3 equal to 0. And we know s1 is sum of the diagonals. The diagonal is 6, 3, 3. So this is s1 is 12. And now next one, s2 is sum of the minors of the diagonal. So the minor of the first diagonal element 6 is, neglect the column and row, 3 minus 1 minus 1 3. And next term, this is a 3 for whose minor is, neglect the row and neglect the column, 6 2 2 3. So this is. And the last minor term for 3 is, neglect the column and neglect the row. So 6 minus 2 minus 2 3. So simplify this. 3 3s are 9 minus a minus of minus plus, already one minus, so 1 plus 18 minus 4 plus 18 minus 4. Simplify, you will be getting 36. So S2 is equal to 36. Next we have to find out S3. S3 is the determinant of the matrix. So determinant is 6 into, you can find the determinant 9 minus 1 plus 2 into minus 6 plus 2 plus 2 into 2 minus 6. You know how to find the determinant of the matrix A. So which is 32. And now substitute these S1, S2, S3 value in the characteristic equation. Because the characteristic equation is lambda cube minus S1 lambda square plus S2 lambda minus S3. But S1 is 12, so minus 12. And S2 is 36, so minus 36 means minus of minus. So S2 is only 36. So substitute 36 here. And S3 is 32, here minus 32 equal to 0. Substitute in the formula characteristic equation. So this is our characteristic equation. So next I want to find out the eigenvalues. For the eigenvalue we have to solve the cubic equation. So generally we cannot solve cubic equation directly. So that first one root we have to identify by putting any other value for lambda. So now first I am going to put lambda equal to 1. So if you put lambda equal to 1 here, 1, so for this term put lambda equal to 1, so 1 cube is 1. So here put lambda equal to 1, so 12 minus 12 into 1 is minus 12. Put lambda equal to 1, so 36 minus 32. Add all the value, it is not equal to 0. So next randomly I am going to put lambda equal to 2. If you put lambda equal to 2 here, 2 cube is 8. 2 square 4, 4 into 12 minus 48. 2 into 36, 72 minus 32. Add all the value, it is 0. So 0 means, so lambda equal to 2 is the one of the root. So we are getting 0 when we put lambda equal to 2. Therefore lambda equal to 2 is the one of the root. So next I want to find remaining 3 roots, because it is a cubic equation. So we found one root only. So by using this, by applying the synthetic division method, I am going to find another 2 roots. Okay, now the synthetic division method is, we have to apply like this. So here the coefficient of cubic equation, first one, lambda cube coefficient is 1 and lambda square coefficient is minus 12 and lambda coefficient is 36 and constant term minus 32. Already we found first root, the first root is 2, so put 2 here. And now here first term always 0, so take 1 plus 0 is 1, 2 into 1 is 2, minus 12 plus 2 is minus 10, so 2 into minus 10 minus 20, 36 minus 20 is 16, 2 into 16 is 32, so minus 32 plus 32 is 0. So definitely we will get 0 here because we are getting 0 when we put lambda equal to 2. So now this is a synthetic division method. Here the end of the term 1 minus 10, 16. So we can form a quadratic equation whose coefficients are 1 minus 10, 16. So now for the other 2 roots, we have to form the quadratic equation with the coefficient 1 minus 10, 16. So this is the coefficient of lambda square. This is the coefficient of minus 10. So this is the coefficient of lambda. This is the constant term. So lambda square minus 10 lambda plus 16. So for other 2 roots, we have to solve this quadratic equation. So now I am going to solve. So it is 16. 16 can be written as 2 into 8 is 16. But I want minus 10. So put minus minus for minus 10. So that it is lambda minus 2 into lambda minus 8. From this lambda equal to 2 and 8. Already we had 1 root 2. Here also 2 and 8. So the eigenvalues are 8, 2, 2. So one different eigenvalue, other 2 eigenvalues are equal. So 8, 2, 2 repeated eigenvalues. So we found 3 eigenvalues, namely 8, 2, 2. And now I am going to find eigenvectors. For the eigenvector, the eigenvector is given by a minus lambda I into x equal to 0. So a minus lambda I means from a I want to subtract lambda in the diagonal only. So already we know matrix A. So the matrix A is, this is the matrix A. So here just I am going to subtract lambda in the diagonal. 6 minus lambda, 3 minus lambda, 3 minus lambda. So this is here 6 minus lambda, 3 minus lambda, 3 minus lambda, that is a minus lambda I. So just subtract minus lambda in the diagonal, and x is x1, x2, x3 and 0 is 0, 0, 0. So now you take it as capital A. So from capital A and by using lambda value I am going to find the eigenvectors. Okay, now I am going to find eigenvector for lambda equal to A. So put lambda equal to 8 in the equation A. So now when you put lambda equal to 8 here, 6 minus 8 minus 2, 3 minus 8 minus 5, 3 minus 8 minus 5. So now I am substituting lambda equal to 8 in the equation A, we are getting this. 6 minus 8 minus 2, 3 minus 8 minus 5, 3 minus 8 minus 5, other terms are same. So now by multiplying these two I can find the equation, 3 equations. So now first row is multiplied with the first column. So minus 2x1 minus 2x2 plus 2x3. Second row minus 2x1 minus 5x2 minus x3 equal to 0. And 2x1 minus 3x2 minus 1x2 and minus 5x3 equal to 0. There are 3 equations. All are different. So now I am going to solve by using cross multiplication method to get the eigenvector. So we can choose any 2 equations, but I am going to choose first 2 equations. So solving first 2 equations by rule of cross multiplication method. The rule of cross multiplication method is, suppose I am changing first 2 equations. The term we have to collect from the second term. The second term is minus 2 minus 5. So take minus 2 minus 5. And the next term 2 minus 1. So this is 2 minus 1. In the next term you take the first one. So minus 2 minus 2. So always end with the starting term. Minus 2 minus 5. Minus 2 minus 5. Choose the term like this. And now apply determinant method. You see 2 minus 2 into minus 1 plus 2 minus of minus plus 10. So 2 plus 10. For x2 minus 4 minus 2. This is okay. For x3 10 minus 4. Okay. So now 10 plus 2 is 12 minus 6 plus 6. Divide 6. Commonly cancel 6. So now we get 2 minus 1 1, which is first eigenvector. The first eigenvector is x1 is equal to 2 minus 1 1, which is eigenvector for lambda is equal to 8. And now to find the second eigenvector, I am taking the second eigenvalue lambda equal to 2. So now put lambda equal to 2 in the equation A. So this is equation A. Put lambda equal to 2. 6 minus 2 is 4. 3 minus 2 1. And 3 minus 2 1. So substitute lambda equal to 2 here. We are getting the matrix like this. So this is the equation. So by multiplying these two, we can form three equations as usual. So first row is multiply with this first equation. Second row multiply with this second equation. Third row multiply with this third equation. But you see here all the equations are same. Because you see when you are dividing 2, when dividing 2 and multiply minus 1, both the equations are same. And divide minus 1, these two equations are also same. So all the equations are same. So we cannot apply cross multiplication here. If you apply cross multiplication method, you will be getting eigenvector 0 0 0. Definitely 0 0 0 is not eigenvector. So that we have to choose different equation only. But unfortunately we have all the three equations are same. So if all the equations are same, randomly choose one. From first one equation, we are going to find the eigenvector. So to find the eigenvector from the one equation, put x1 equal to 0. If you put x1 equal to 0, remaining minus 2x2 plus 2x3. And now take plus 2x3 here, right hand side, minus 2x3. And minus minus cancel, 2 also cancel. So x2 equal to x3. x2 equal to x3 common taken as x2 by 1, x3 by 1. So already we assumed that x1 equal to 0. So 0, 1, 1 is the second eigenvector. So x2 is equal to 0, 1, 1 is the second eigenvector for lambda equal to 2. Okay, I am going to find third eigenvector. But you listen, in the three eigenvalues, two eigenvalues are equal. First eigenvalue is 8. Second and third eigenvalues are equal. So it is 2. So now already we found eigenvector for a lambda equal to 2. So even though if two eigenvalues are equal, we have to find out third eigenvalue which is different from x1 and x2. So now I am going to apply orthogonal property, because two eigenvectors are orthogonal to each other, because the given matrix is symmetric. In the symmetric matrix, orthogonal eigenvectors are orthogonal to each other. So now I want to find out the third eigenvector which is orthogonal to both x1 and x2. So now I am going to consider third eigenvector x3 which is ABC be the third eigenvector which is orthogonal to x1 and x2. So now orthogonal to x1 and x2. So x3 is orthogonal to x1 and x3 is orthogonal to x2 also. Orthogonal means perpendicular. The perpendicular means dot product becomes 0. Already you know, if two vectors are orthogonal, then dot product between these two is 0. So similarly, x1 and x3 are orthogonal. So the dot product between this and this 0. That means if x1 eigenvector is 2 minus 1 1. x3 eigenvector ABC. Multiply these two. 2 into A, 2A. Minus 1 into B, minus B. 1 into C, which is equal to 0. Because x1 and x3 are orthogonal, so dot product becomes 0. Similarly, x2 and x3 are orthogonal to each other. x2 is 0, 1, 1. So now x3 is ABC. So dot product between these two. 0 into A, 0A. 1 into B, B. 1 into C, C. So dot product becomes 0. So we found two equations. Both are different. So again by using cross multiplication method between these two equations. So A, B, C, already you know how to choose the coefficient term. The coefficient term is start from the second term. Second term is minus 1, 1. So it is minus 1, 1 and 1, 1 and the next term is 2, 0 and end with the same term minus 1, 1. So now the cross multiply A by, so multiply these two, minus 1, minus 1 and now B by 1 into 0, 0 minus 2 and C by 2 minus of minus plus 0. So now A by minus 2, B by minus 2, C by 2. Divide by minus 2. So we will get A by 1, B by 1, C by minus 1. So the corresponding third eigenvector is 1, 1, minus 1. So which is third eigenvector. And also all the eigenvectors are orthogonal to each other. Okay, we found three eigenvectors x1, x2, x3. x1 is eigenvector 2, minus 1, 1. x2 the second eigenvector 0, 1, 1. Third eigenvector 1, 1, minus 1. So correspondingly I want to find out the normal form. So normal form of x1 is this 2 by root 6, 1 minus 1 by root 6, 1 by root 6. So normal form we have to find. Actually the first eigenvector 2 minus 1, 1. You see first eigenvector 2 minus 1, 1. Whose corresponding normal form? To find the normal form we have to find out the root value. Root value of root of sum of the squares. 2 square 4 minus 1 square 1, 1 square 1 equal to root 6. This root 6 must be divided by each term, which is the normal form. So take root 6. This root 6 is divided by this 2 by root 6. So this is 2 by root 6. And next to minus 1. So minus 1 by root 6. So this is minus 1 by root 6. And next to 1 by root 6. So this is 1 by root 6. So this is a normal form of the x1. Similarly, I am going to find normal form of x2. x2 is, here terms are 0, 1, 1. So root of 0 square, 1 square, 1 square is 2. So root 2. So divide root 2 in each term. 0 by root 2, 1 by root 2, 1 by root 2. And correspondingly, the normal form of the third eigenvector. 1, 1, 1. So the root of 1 square plus 1 square plus 1 square is root 3. So normal form 1 by root 3, 1 by root 3, minus 1 by root 3. So these are all normal form of the eigenvectors. Now from this I am going to find the normalized model matrix N. So which is normalized model matrix N. So the normalized model matrix N whose columns are eigenvector normal form. So this normal form take it as first column. This normal form you take it as second column. This normal form take it as the third column. So this is N matrix, not a normalized model matrix. For the normalized model matrix, we have to find out N transpose by the working rule. So find the normal N transpose. N transpose means each row is changed to column. Second row is changed to second column. Third row is changed to third column. So now N normalized model matrix whose N transpose is this. So N transpose O. So next we have to find out D. By using N and N transform, I am going to find D, that is a diagonalized matrix. Calculation of D by using orthogonal transformation. So now I am going to multiply N transpose into A. So this is N transpose, already we found it. This is A, from the given quadratic form we found A. So multiplication of these two. So by multiplying these two matrix, you will be getting this. So multiplication not easy because we have so many root terms. So for the multiplication, you don't want to use root term. Simply you find out multiplication of ordinary terms. For example, when you remove the denominator term, the terms are 2 minus 1, 1, 0, 1, 1, 1, 1, minus 1. This matrix is multiplied with this. For example, 2 minus 1 means you can choose 2 minus 1, 1, 0, 1, 1, and here 1 minus 1 minus 1. So for example, this is a matrix. For this you consider only numerator term. And the next term, this is A. A is 6 minus 2, 2, and 2 minus 2, 3 minus 1, 2 minus 1, 3. you just multiply these two matrices. In the resulting matrix, you divide root terms. That means in the resulting matrix, you divide root 6 in the first row, root 2 in the second row, and root 3 in the third row. So this is n transpose into A. And now in the n transpose into A, I am going to multiply n. So this is n transpose into A. In this I am going to multiply n. This is n. So by multiplying these two, we will get capital D. So to find the capital D, we have to multiply these two. But it is easy because first row is multiplied with the first column. Here also root 6. Here also root 6. Root 6 into root 6, 6. So first term is by 6. And we have multiply as usual multiplication. So now this is a resulting matrix of multiplication of n transpose A into n. You see, multiplication of first row is multiplied with the first column. You will be getting 48 by 6. And the first row is multiplied with the second column. You will be getting 0. So that it is 0 by root 6 by root 2 is root 12. So obviously we will get only values in the diagonal. Other elements are 0. So and also 48 by 6 is 8. 4 by 2 is 2. 6 by 3 is 2. You see the diagonal element. The diagonal elements are 8, 2, 2, which must be eigenvalues the same order. So we found eigenvalues 8, 2, 2. This is the diagonal element 8, 2, 2. So which is diagonal matrix of the matrix capital A. And now, but the question is we have to find out the canonical form. To find the canonical form, from D we have to find the canonical form. The canonical form is the row matrix y1, y2, y3 into D and the column matrix y1, y2, y3. So now this is the quadratic canonical form y1, y2, y3. We found D, substitute here 8, 0, 0, 0, 2, 0, 0, 0, 2 and the column matrix y1, y2, y3. And multiply these three matrices, you will be getting 8 y1 square plus 2 y2 square plus 2 y3 square, which is the canonical form of the given quadratic form, and also whose coefficients are must be eigenvalues of the matrix A. So which is canonical form of the given quadratic form.